Okay, so in this second little tutorial about the transport of water through the xylem, we're going to talk about how the water goes all the way from the root xylem up through the xylem in the stem, into the xylem in the leaf, and then into the cell, because of course it's the cell that needs the water for photosynthesis. So the xylem itself has certain adaptations that allows it to carry water. You can imagine there's going to be quite high pressure exerted, and so it'll have to have reinforcements. It has lignin in the wall of the xylem. The xylem cells start off with all of their organelles, and then all the organelles dying and are got rid of, and so the cells in the xylem tubes are empty, hollow, and the ends of the cells break down as well, so you have this continuous pathway for the water to travel up through the xylem. Okay, so it actually all starts up here, this force, this pulling force. So this cell here is using water for photosynthesis, but some of the water evaporates out of the cell and goes through the stomata and into the atmosphere. And it's this that kick-starts the pulling process of the water up through the xylem. So I'm going to write down, I'm going to number these stages and write them down. So number one is all to do with the water evaporating from the leaf. Let's write that down. The water evaporates from the leaf cell. And of course, if there's less water inside the cell, there will be proportionally more solute. And what that does is it lowers the water potential. That's important. This lowers the water potential inside the cell. Okay, so now this cell is right next to the xylem. Because it now has a lower water potential, the water inside the xylem, where there is a slightly higher water potential, can now go into the cell. So let's write that down as well. This is number two. So number two, if we write it up here, make sure you can see it. The water enters the cell from the xylem, and it goes from a high to a low water potential. And that's why the water goes in that direction, because now the water potential is lower here. It can go from a high to a low water potential. And of course, if you're going to be talking about water potential and water moving, it's always a good idea to mention the word osmosis. So let's write that in. By osmosis. Good top exam tip there. Okay, so what's interesting is that now let's draw in a little water molecule here. Can you see that little circle there? There's meant to be a water molecule. That water molecule is going to enter the cell, and because it's stuck to other water molecules, so that water molecule is stuck to that one, and this one is stuck to that one, and that one's stuck to that one. They're all stuck to each other because of the properties of water that we'll talk about in a minute. They all get pulled up. If that one enters the leaf, all the rest of them will be pulled up behind it. So this concept is number three. Let's write this down. Quite a lot to write here. So the water molecules are pulled up in a continuous column. Are pulled up in a continuous column. And the reason for this is to do with the properties of water molecules. So you might remember from an earlier lesson at the beginning of your course that we talked about the properties of water and the fact that they can form hydrogen bonds with each other. And there's a word that describes this. Water molecules are cohesive. So just a quick reminder of what's happening here. So here's a water molecule. It's made up of an oxygen and a couple of hydrogens, we know that. And because of the slightly more electronegative aspect of oxygen, it's slightly more negatively charged, and the hydrogen is slightly more positively charged. And so if it encounters another water molecule, it will be attracted. The opposite charges will be attracted to one another. Okay? So this here is a hydrogen bond. They form hydrogen bonds with each other. So if you ever have to write about this process, it's a really good idea to write about hydrogen bonds. Yeah. The other thing that water molecules are able to do because of this feature, because they have this slightly negative charge on the oxygen and the slightly positive charge on the hydrogen, is that they're able to stick to other molecules that have hydrogen and oxygen in them. So let's write this down. The water molecules are also adhesive. And so this is a little bit different to cohesive. If they're cohesive, they're sticking to each other. If they're adhesive, they form hydrogen bonds with other molecules that have hydrogen and oxygen in them. For instance, the xylem that makes up the walls of these xylem vessels. Yeah. So they form hydrogen bonds with the xylem. And what that does, and you've got to imagine now that you're sucking on a straw, and if you suck really hard on the straw to pull the liquid up, sometimes the walls of the straw get pulled inwards, and that's what's happening to the xylem here. Yeah, so let's write that down. That's a really important point to make. Pulls the walls of the xylem inwards. This is called a negative pressure. So pulling the walls of the xylem inwards, making the diameter of the xylem slightly smaller because of the pressure of the water molecules being pulled up. It's called a negative pressure, and sometimes it's called a tension. It means exactly the same thing. So let's just recap. Number one, the water is evaporating from the leaf cell, and this lowers the water potential inside the leaf cell. That means that water can enter from the xylem and go into the leaf cell, and from a high to a low water potential by osmosis. And as that water molecule enters the leaf, it pulls the other water molecules up behind it because of the properties of the water molecules, because of the fact that they make hydrogen bonds with each other. And at the same time as these water molecules are being pulled up, the walls of the xylem are being pulled inwards. A negative pressure is being exerted. So we call this theory the cohesion, that's referring to the water molecules, tension, that's referring to the xylem walls being pulled in, theory of transporting water through plants.